Hi, I'm Mr. Evans, and we're going to continue our talk on motion graphs, this time though emphasizing velocity versus time graphs, which in my opinion I think can be a little bit trickier. So let's go ahead and dive into some graphs. Similar to our last video where we covered displacement versus time, I want to begin here with a graph where we just analyze what the different slopes mean. And so, in this case we're doing velocity versus time, and let's start with A. And so we have a positive slope going up, and what this represents is constant acceleration. And so notice it's not constant velocity because now we're working with a different graph. It means constant acceleration. And so if this person started at zero velocity, which would mean, no motion. Let's say it's a person walking, they're standing still. And now they're up here and they're moving at, let's say 5 meters per second. This means they constantly accelerated, they sped up. And so that's what A represents there with that positive slope. B is a flat line. And so before, in displacement versus time, that meant no motion. However, this is key, that no longer is the case. And so the person for A went from 0 meters a second to 5 meters a second. Well, now they're staying at 5 meters a second, right? And so that flat line at B actually means constant motion. If they were driving a car, for example, that's when you're on the highway and you go 60 miles per hour, you put it on cruise control and you stay at 60 miles per hour. That's constant velocity, and that's what's going on in B. On C, you see a negative slope, that downward slope. Again, it's a straight line, so this means a constant acceleration. Okay, in this case, so it's a negative acceleration, and what that means is the object is slowing down. So it's doing the opposite of A, but that still counts as acceleration, and that's important. I want to point that out. A is acceleration, and point C is also acceleration, even if it's a negative acceleration, or what some people would call it as deceleration. Point D, okay, I really want to point this one out. B is constant motion because it's a flat line. D is also a constant. It's also a flat line, but I don't know if you want to call it constant motion because it's not moving. And so that's how B and D are different. If I drew another line right here as F, B would be constant motion, constant velocity. F would be constant velocity in motion. D is also a constant velocity, but it's 0, and so it's no motion. So B and F are constant motion at the same speed. D is no motion. And finally, E I just drew just so you could see where D started and end. But E again is that constant acceleration. It's going up, it's a positive slope, and so it's a positive acceleration, meaning the object is speeding up. Whereas C, the negative slope, means negative acceleration. The object is slowing down. And so with that in mind, we're going to move forward. I'm going to draw a different graph on here, and we're going to start working with a little math. And in these ones, velocity versus time graphs, you actually solve for acceleration. Okay, so to do some math, I drew another graph. Again, simplified it a little bit, but also gave us some room to do some work. And so we can solve for acceleration. So let's start with line A. So line A starts here and ends up here. And so we need to remember our acceleration equation, which is acceleration equals change in velocity over change in time. So if I work over here on the right side of the screen, I need my change in velocity. And so if you look at the graph, again, final velocities first. Our final velocity is up here where it was 40. So we have 40 minus our initial velocity, and in this case, our initial velocity was 0. Over change in time, our final time, again, is right here, which if you draw a straight line down is 10, and our initial time is 0. So in this case, you end up with 40 over 10, and so our acceleration is 4 meters per second squared. Okay, and remember, it's important, it's meters per second per second. And so for these first 10 seconds here on the graph, we sped up 4 meters per second every second for the first 10 seconds, which got us to 40 meters per second. Okay, so if we go ahead and, let's try to solve for another section by getting this stuff out of the way. Okay, and so now let's move on to solving for, let's call this point or line B. Okay, so now we're going to solve for line B. So again, we need change in velocity. So we started here, and we're ending here. And remember what I said is you start with final velocity. So our final velocity is at that endpoint, which is down here. And so let's draw a straight line over. And our final velocity is 20. Minus our initial, which was up here. Draw a straight line over, and that's 40 over time. And again, time's going to be trickier because we're not starting at 0. And so let's draw a straight line down from our final. Final time is 30. Initial time, straight line down, is 20. Okay, so 20 minus 40 is negative 20. 30 minus 10 is positive 10. And so you end up with negative 2 meters per second squared. Now that negative might throw you off for a second, but keep in mind, negative acceleration is possible. All that means is you're slowing down. And so that makes sense, right? At the initial point, up here where I circled, we were going 40 meters per second, and now we're going 20 meters per second. Did we slow down? Yes, we did. Hopefully, this helps you out with your calculations. Definitely use this going forward. You'll notice that we did not solve for, let me make this point C right here with this flat line. And we didn't solve for it, and we could have, and I could give you an example really quick. Why don't I just go ahead and do that? So let's erase this stuff off to the side, and let's solve for point C. And give me my pen back. Line C here starts here and ends here, and it's a flat line. So let's see what type of acceleration we get. We have our final speed is 40 right here. If you draw a straight line over to the left, you get 40 meters per second. Our initial was 40, and our time, if you go down, ended at 20 and started at 10. And so what happens is 40 minus 40 is 0. It really is a moot point on what goes on the bottom because you have 0 over whatever. And so that means 0 acceleration. And that makes sense, right? We have that flat line. That means a constant velocity. That means we're not changing speeds. And so that's why we didn't initially solve for C, because we get the answer of 0. Hopefully this helps clears up motion graphs for you. And please let me know if there's any questions or if you would like to see a video of a more challenging problem.